Hi, I'm Carol Willis. I'm the founder and director of the Skyscraper Museum and the curator for this exhibition, Tall Timber, the Future of Cities and Wood. As you all know, and the reason you're here, Michael Green is speaking tonight and is one of the many architects whose work is included in the exhibition that will be speaking in this series, which also includes structural engineers and academics. In fact, I'm going to preview some of the other talks that will be coming in the upcoming weeks, because this lecture series really brings together the key figures in the mass timber movement. And I'll introduce Michael a little bit longer with the history of how I guess I encountered him and how he figures in the exhibition in a moment. And also Joanne Gonchar, who will engage Michael in conversation after his talk. So now I am finally going to ask Michael to come up and to talk about this. His title is The Evolution of Mass Timber, but also how his work expands the theme, but is consistently focused. So he is one of the great communicators, and I don't like the word storyteller. I prefer the word explainer. But in terms of communicating a clear, I know you do, and I think that's how you approach your talks. But the story is told with such clarity that it explains things in a way that stories may just entertain. So he really is one of the great clarion voices for mass timber, and I'm really grateful for him to be here tonight.
Thank you. I will probably storytell, because it is about how we change minds, change ideas, and make this happen. And it's fun to talk to you all, because it's like talking to the more than converted, a lot of the leaders in the industry. So I appreciate you all being here. And there's some good friends in the audience too. It's nice for me to be on the East Coast, truthfully. I spent a long time in New Haven, Connecticut, and upstate New York, so it's very familiar to be here, and I appreciate it. So our firm is based in Vancouver. We have an office in Victoria, the bookend of this little stream. And I've written London, New York, and Barcelona because technically we have people in all three places. And we are working to have offices in two of those places, both here in New York and in Barcelona. We have a senior designer who's Spanish in Seville, which is far too hot for me. So I'm trying to twist her arm and open the office in Barcelona as the plan. As well as a new person, wonderful senior person who was a partner at Mass Design is joining us and is based in London, and will probably be actually working out of Barcelona as well. So, so that's where we're from. We are somewhat unique, certainly in North America, in that when we started our practice, we decided we would only build in wood. We would only build with a climate focus, and we've been really fortunate. You can't read the numbers on there, but we've built an enormous number of mass timber projects and wood projects all over the world. And that blurry photo is the team with my partner Natalie here on my to my side. Natalie helps me run the office. We're 45 people in Vancouver, and in the back, Eva is the head of communications, and she's here with us today. So that's a bit of kind of context. I call this, I renamed the talk to being Tall Wood, a brief self-serving history. Because this is just the story I can tell. And it starts with a little bit of a story of why this became compelling to me, and I thought it'd be fun to share. I gave a talk at Cornell, which is my alma mater, and one of my professors, who's now very, very elderly, asked me, "Why do you do this? He literally pulled me aside and said, 'You seem like a do-gooder with your motives here, and are you somehow religious? Is that why you're doing this?' And I was like, "No, I actually live on a planet that is warming very quickly, and I have kids and I care." But the real motivation for me comes from the three skyscrapers in my life that are pretty defining. And so the first is the one we all know. I worked for Caesar Pelli during the time Caesar was designing the Petronas Towers. I was a very young architect. I'll mention it again with Minnie here. And Tony and Kristen are here, who are very, very dear friends of mine from Caesar Pelli time. Where they are here. Right there in front of me. And so a big part of my life. The other forest, or the other skyscraper in my life, is the trees and the forest, because I live in BC, where trees are massive. And it's a very different experience to walk through trees where I live and maybe live in the Pacific Northwest. And the third is mountains. So I've lived my life heavily focused on climbing, and these three are pretty equal in my life. And so I thought it was a good way to start, because the last two here really are the motivation. It's the more time I spend in remote cultures when I'm climbing and learning about the reality for the rest of the world, not the developed world. And the more time I spend in the forest, the more time you want to protect and save and address these big existential issues of climate. Hopefully you guys all recognize this person. He was my boss for the first 7 years of my career, 8 years of my career. That's Cesar Pelli, who I'm sure is very well represented in the skyscraper context, and was a wonderful mentor for me, as was Tony here in the front row. Is really my mentor through my time at Cesar Pelli's office. And the reason I mentioned Cesar is that I was like very much this 20-year-old kid that didn't feel like I belonged and running off to climb mountains as much as I could. And actually, honestly, had a hard time connecting with the work we were doing in big buildings and steel and concrete and all this. It wasn't really in my DNA. But when I told Cesar I was leaving, moving back to Canada, where I grew up, and to British Columbia, he said to me two things that I'll never forget. He said, "Good, finally the dress code will improve around here." And the second thing, which was just showed me how intuitive he was and how much he knew his entire team, he said, "I think you'll really like it. They like wood there." And that was back in the late 1990s. And the fact that Cesar somehow knew that about me already and actually ended up prophesizing the career I ultimately had was pretty remarkable. I mean, it was a really great guy. Anybody know who this is? This is the other mentor I'm going to mention. Anybody know? This is
Bob Villa.
No, not Bob Villa, but close. That's Norm Abrams. And this, so New Yankee Workshop and this old house. I learned to woodwork through my time at Cesar Pelli's, and everything I know about wood pretty much came from this guy. Watching him on Sunday mornings, and I had the opportunity of speaking for the show, This Old House, and doing a podcast in the middle of COVID, and literally I said, I'll do absolutely anything Norm asked me to do. Understanding wood as a woodworker, working with it in your hands, understanding how wood moves, how it changes, how it warps, how it twists, how it glues together, different species of wood, what it smells like, what it tastes like, all the things about wood that you can learn with your hands are things that actually are transformative, what you can build very big buildings with. So for me, my education started at this very intimate understanding of wood and spending a lot of time with it, which I still do. When I moved home to BC, the thing that changed for me was that, you know, I had a traditional career up until the point where I went home, other than doing a lot of this stuff in the big mountains and really watching what was happening with climate change. And I really started to recognize back in the big wilderness of the West Coast that climate change, as you guys all know here, is a huge contributing factor is the built environment, 42% globally. And even though we all know this, we just keep having to say it out loud because the public do not know this. I speak at a lot of climate change conferences. I spoke at Aspen Ideas, and there were 800 people in attendance. One person speaking about the building industry, even though we are 40% of the problem, and in North America, we're almost 50%. One person talking about what we do in our industry, and yet we are the biggest contributor by far. And our voice and our power and our voice as specifiers and specifying the largest volume of material that man makes on Earth is what architects and engineers and builders work with. Means that we have voice, we have agency, we have power to make change happen, and we have to be motivated to do it in these new ways that are hard. This tall building movement, we're going to talk a lot about it, but it's been a grind. It's been hard work to get us to where we are, and we have a long way still to go. But for me, it was actually started in my backyard, building this building with my own hands. This was when I finally realized after 8 years doing some pretty fun buildings at Cesar's office that maybe I kind of knew what I was doing. And reminded me that building in wood was something that I could really feel connected to. And it really changed my career. I built airports, a lot of them. Again, sorry for the image quality. These are timber airports. And started to learn a lot about what the machinery, the heavy machinery, could do for us when working in wood. And so I'll stop at this column, starting to understand how a lot of the new cutting tools could reshape engineered wood. And in doing so, what that could mean for the strength of wood in different ways was really important in the early days for me to understand. At that time, just heavy timber, right? Glue lambs, engineered heavy timber. And then we got this phone call at the office in 2004, and it was Austria on the phone, and I didn't know what that meant, but what it meant was the Olympics were coming to Vancouver, and the government of Austria, for some reason, picked us to like build Austria House, which made no sense. I'm not also Scottish, I'm not Austrian, but they wanted us to come to Austria and visit and learn about Austria so that we can come back and build. Two critical things in their mind was they wanted to show CLT and what it was, and they wanted to show what they were doing with Passive House in Austria. And both of those for me were a huge education. So I went over to Austria, I toured all of the early plants, making CLT, and went and met with universities. The Austrian government gave me this amazing tour and education, including Passive House. And in that process, I really got to know an architect named Herman Kaufmann. If you don't yet know Herman Kaufmann, he's really probably my biggest hero as an architect. The most rigorous architect I know is from Western Austria, and teaches in, I think, in Munich right now. But his practice was doing a lot of these early versions of mass timber buildings before it was called mass timber. I'll talk about that in a second, but CLT buildings. And in a really rigorous way, very focused on energy and very focused on what they could do with the material. But the early origins of CLT, if you don't know, is that the housing market in Austria was about 20% wood, and the rest was like concrete block. That's how people built housing. And so the wood industry in Austria decided that they really needed to come up with a way to use more wood. And they looked at North America and the way we build our homes in dimensional wood and light wood frame. And they said, no way, it's too, you can hear your neighbor through the walls. There's no way we want to build that way. So let's develop a product that has the weight and mass of a competitive product of stone and masonry. And that was really the origin of CLT. It was a way they could break into the market as wood producers. The problem was most of the buildings that I got to see at that time were 2 stories tall. The code in Switzerland at the time was 2 stories maximum. In Austria, they could build up to about 4 stories, but nobody dreamed of building bigger. And so I came home to Canada thinking, great, this is an amazing material. I live in the center of forestry in British Columbia, and we should build this way. But there is no way it's going to be cost effective to build 4-story buildings in this massive wood, because we already build light wood frame buildings, right? It's already cheap to build a light wood frame building. And so how on earth is that going to actually happen in the North American context? And that was really, for me, the beginning of this sort of idea of tall. The only way this material would have any legs in the North American context is it had to be bigger than 6 stories. In British Columbia, at that point, we just elevated light wood frame to be allowed to build 6 stories. Well, a lot of North America was 4 or 5. But even 6 was not going to be economical. And so really that said 8 is going to be the target. And I had the good fortune of being able to start lecturing. I'd already built a lot of wood buildings, and I was running around the world lecturing and talking about, we used to build big tall wood buildings, right? We used to build stave churches in the Nordics and these amazing temples that are 1,000 years old in Japan and so forth, or even at home in Vancouver. This is a 9-story building that's still standing and very close to where our office used to be. It's 110 years old. It's built in an earthquake zone, and it's a timber building. And these used to populate New York, Chicago, Toronto, Vancouver, all across North America. We used to build this way, and then we stopped. So these ideas weren't new. They were just about bringing them back. And now we had this new material, CLT, right? So I think most of you all know what CLT is, but layered jumbo wood to make huge panels. The problem is Europe had it, Austria had it, but we didn't have it at home. And so I was designing not a big building, a building that was a city hall building, and we didn't have CLT in North America. And so this is the origin of the word mass timber. It's kind of crazy to think, but because we didn't have CLT, we needed to create a family of materials. And so these materials already existed: laminated strand lumber, laminated veneer lumber. There's a whole bunch more mass timbers: dowel lamb, nail lamb, glue lamb on the flat. But nevertheless, that became this family of materials. And so that was the beginning of the word and the name mass timber. was simply because we didn't have it in North America, that we needed to elevate these products that were stick products. They were made in parts, not in panels. They produce them in panels, chop them into sticks. And for us, the project that was kind of the beginning of that was this city hall we did in North Vancouver, where we wanted to build this central atrium for the city hall with a flat, shallow truss, and we wanted to do it in CLT, but we couldn't get it. It didn't exist in North America, and shipping it from Austria to British Columbia was apparently politically not popular. So what we did instead was we used laminated strand lumber and really started branding this idea that there were many different products you could build with, like, and call it masthead. And that's the origin of the masthead word that we all use today. It was also the beginning for us of panelization, learning how, in this case, we could build these 12-foot by 30-foot panels offsite, complete with insulation, electrical built in, and these very flat, shallow truss-like panels to build a building. And of course, it's not tall. So at the same time, as I'm lecturing around the world, I end up meeting and honestly totally fall in love with this guy named Andrew Waugh in an appropriate way, especially because Andrew's daughter's here. So Andrew became an incredibly good friend of mine, and Andrew was lecturing alongside me, talking about wood. And in 2008, 2009, built this building, which is the first tall wood building, modern tall wood building, and a really important milestone. And it was built using Austrian wood. Andrew's coming to tell this story, so I won't tell too much about it, but it was a really instrumental moment for the industry. And for me personally, it was the beginning of both our friendship and our relationship, but also an understanding that we were already starting to explore tall, but in a very different way than Andrew was. This building is built as a platform-based building. So it means the floors go on and then the walls, and the floors go on and then the walls. That's kind of how we build like wood frame construction. But I live in an earthquake zone, right? The West Coast is a heavy earthquake zone. And that system of building wasn't going to work for us as we went higher than 6 to 8, 9 stories. And so we knew we had to come up with a very different system in order for us to build in our seismic zone. And that was what began this book that we call The Case for Tall Wood Building, is the reason why we should build it. And we developed this system that was balloon frame. So that means that the walls go up many floors and the floors are hung between, which as you go taller and taller becomes really important because wood shrinks. Wood shrinks in the horizontal across its depth, but not in the vertical. The tree doesn't shrink over its height, it shrinks around its curve. And so when we go vertically and then hang floors between, we knew that we could build much taller. And that was the beginning of our understanding of what we might do and why we might do it, and started to really advocate for it. And there was a really critical moment for us in this process that was unintentional. I'm going to tell you a whole bunch of unintended things that come from like total accidents that happen. One was this, I just read about Creative Commons licensing. And so when we wrote this book, I wrote a little thing at the beginning and said, this will be Creative Commons license, which meant that instead of it being proprietary, it was under a totally open license that anyone could pick up any of the ideas and use them. And it had this sort of non-commercial share-like attribution. That's the definition of the Creative Commons. And I just read about it. I thought this is a great idea. We'll do it because nobody should own the patent on ideas like this if we want them to populate the world. But what I didn't realize at the time is a lot of media later came to me after this book was published, and it was like a curiosity, right? What are you talking about? Building a skyscraper out of wood. And they said the reason we wanted to talk about it is because he gave it away. If you had owned this, the proprietary rights to it, we would have not, that's advertising. We would never have written about it. But because you gave it away, it felt sort of weird to us that we were interested in talking about it, because who does that? And I never thought about it, but it's true. The more you share, the actual more that returns back. And that actually helped us get the message out a lot quicker than I think we otherwise would have. So that generated a lot of press. And finally, we got to build the first CLT building for us in North America, which is this one. Not like this is actually the first CLT building in North America. And it was for Ronald McDonald House at BC Children's Hospital. So it's for 75 families with kids with cancer. But it's only 4 stories tall. So we wanted to say that this material, apologies to the Skyscraper Museum, but we're going to get there. But we wanted to show this idea of FFTT, and we wanted to show the idea that these systems of building using CLT would work at all different heights and have a reason at all different heights. And so this was a chance to say in an institutional building that needs to last for generations, CLT made sense. So we tilted up these walls vertically, like again, a balloon frame, and then hung floors of light wood frame to keep the cost down because it was tall. And so for us, this was a very instrumental turning point of understanding that these systems could be economical. We could actually achieve them and achieve the architecture we wanted, including brick on the outside. So we weren't married only to the idea of, putting wood on the outside of a wood building, right? But then it came to this big question. All right, so a bunch of people, some of you in the room are starting to really germinate on how we're going to get this movement to work. And I'm sure those like Thomas and others in the room that have experienced this, everybody says that can't be done. Our industry is a massive ship that cannot be turned. Like there is no changing the way. So the industry largely hasn't seen any major innovation in the century. It's kind of embarrassing. Every other industry sees massive innovation. We pretty much built buildings the way we did a century ago. And yet we are so responsible for so much important issues from social to climate and so forth. So turning the ship became the big question of how to do it. And there was a real life lesson in it. And that was to find tools to tell the story. And so we were approached by a Finnish company, Metsä, who make a laminated veneer lumber. And they asked us as part of their program, we'll pay you a bit of money. Could you sit down with your engineer, Eric Karsh, who's going to speak as well. And he's a very important engineer, a good friend of ours. He shares office space with us in Vancouver. And could you guys figure out, could you have built the Empire State Building entirely in wood? And what we found is we definitely could have, which is kind of crazy to think about. But we did a pretty detailed engineering exercise to prove it out. We came up with a concept of post-tensioning laminated veneer lumber sections. We actually did pretty detailed drawings of it. But it also, which I don't typically show an audience, but in that process, what it allowed us to do is talk to the mainstream, right? And the big thing about skyscrapers, the reason this is such an important part of this movement is that, and I think Andrew Law, when he comes, he speaks, will say the same. It's not just about tall, it's about more, it's about bigger, it's about more urban. And it's really not just about tall, it's just more. The thing is, the breakthrough of any new technology has to be inspiration. It has to stretch your imagination of possibility, and tall does that, right? When you want to build a 10-story building and this new technology, it's still scary for people until you realize, well, somebody built 60 stories. All of a sudden that takes the fear away. There's a whole history of how this worked, even in the beginning of skyscrapers a century ago. In my TED Talk, I'll talk about how people were terrified to walk under a 10-story building, the first tall building, the 10-story building in Chicago, because they'd never seen anything like it, right? So that fear is something we had to overcome. And tall was a way we could show that if we could build the Empire State Building, if we could show with some real examples, like we see in the room here, then we could actually get people really comfortable with any other height with this material. And so the breakthrough is going to be about tall, and really the inspiration of, the dialogue between the Chrysler Building and the Empire State, and the competition, the spirit that developers feel about, being a little bit taller, and all of the things that this museum are about, is really what also pushes innovation, pushes engineering higher and higher to create this great comfort with change. And so these tools for us to be able to tell the story became really important, with cute little things like that help get the everyday person kind of adjusting to it. So there's I always say that our industry hasn't changed in a century, but the health and safety standards have changed a little bit.
Be wearing hard hats now.
Yeah, exactly. And maybe rope it. But New York is like,
Somebody did one with women.
Oh, yeah.
With that, we should update that. That's true. But it speaks to this idea that New York has held this center of excellence in this arena for so long and showcasing what can happen here, right? And that's why New York, thankfully, started to really take this seriously, because New York has always been this leader of building technology, and now it's not, right? So that can change Chicago too. So the other story I like to tell, because it's the kind of accidents happen that are great accidents that make changes happen, is the story of when we wrote that tall wood book. And when Andrew was going out speaking and I was speaking, we were always talking about, 12-story buildings. That's kind of what we thought. Andrew had built 9. I'll show you the second building we did that was just a hair taller than the second building. But we weren't really stretching to huge heights. And I was talking 12 everywhere I went. We could build 12 stories, and the problem is technology works. And then I went, Greenpeace weirdly asked me to go to Australia and debate this climate change denial. I had to go to 10 different, it was a really strange experience for me. And I had to go to 10 different conservative think tanks and debate this guy. And the first one was the only people that were my people. It was the Green Building Council in Australia. And afterwards, I told the story of that airport, which is in a town called Prince George, which is a small town in northern British Columbia. And I told the story about that airport, and then I told this idea we could build tall wood buildings. And I met with a reporter right afterwards. And when I was meeting with her, I don't remember exactly, but she asked me, well, how tall could these buildings go? And I think I must have said, I don't know, 10, 12, 30 stories, who knows? But kind of casually said it like that. I get on the plane, my daughter was with me, she's a little girl. We get on the plane and it's Air Canada, and they hand me our national newspaper, Globe and Mail. And the front page says, Canadian architect is building 30-story tall wood building in Prince Rupert. Prince Rupert is a town of like 5,000 people. And the head of the Chamber of Commerce called me and said, are you building a 30-story building in our town? We didn't know about it. But the point was, it was like a huge error that got picked up around the world. Like it went out onto AP and everybody thought I was actually building a 30-story building. And it was the single best thing that happened, because I went home to our engineer, Eric, and said, can we figure this out? Because we're going to have to figure this out. They think we're going to be able to do it. And it took us a week, and we figured out that, we could easily do 30. And then we realized, we could probably do 40 or 50. The technology is there to do these things, even in a high earthquake zone. So 12 went to 30 pretty quickly. And I like it because we had no intention of that change. That happened by accident, and I'm really happy about it. That led to the first book and the beginning of these sort of idea that this was popping up around the world, right? You see it here, but all over the world, these ideas were starting to percolate, just beginning to. And really, again, I think Andrew and I at that time were just doing a ton of lecturing, and it was really all we then won this project with the British Columbia government, which was our first tall wood building. It's not very tall, but it was really important. It's in Prince George. It's in that town. That's not that big. And so they didn't need a bigger building. We couldn't put anything in this building. It's for a university. It's a very tall floor to floor, and it was literally like a half meter taller than Andrew's building, which I think he still gives me shit for. So it's not very tall. It's actually not very, it's only 8 stories tall. And but what it is 100% wood and then different technology. And it started to be a way that we could explore other kinds of building programs in these buildings at height. So whereas Murray Grove was a residential building, so small cellular rooms, this is a university and office building, so big open spaces. And so we developed and we started design and finished construction in 14 months. It was the first of its kind. It didn't meet the building code. We had to break all the rules, and we had to test all at the same time of delivering a project in 14 months. So anybody that builds, you'll know that's very fast. And we were flying and testing these things as we went. And we developed a system of staggering CLT that allowed us to hide all the services in the building's floor sandwich, which was really cool, except we've never actually done it again. So, but it taught us a lot of lessons. And part of the lessons are these buildings are different. The process is different. You're not, you're not sort of saying to the engineer, make the structure, and then saying to the mechanical, figure that out. It's, day one with structural, mechanical, electrical in the room, we're collaborating to figure out how all those things work together, because you want to show off the beauty of that material. And this was the first building for us to really deeply understand how integrating into the structural system meant that we were actually thinner as a sandwich than a conventional concrete building. But we could do it in a much more beautiful way, and obviously a much more impactful way from a climate point of view. Even the core CLT, this is the first use of CLT made in British Columbia. And And even the exterior is wood, which is really unusual. We actually charred the wood in the Japanese technique to prove that the flame spread on the building would match steel or a non-combustible exterior, which it barely did, but it did. What we found, though, is more important, which is we did a bunch of studies and we found that it was 88% reduction of carbon over doing it in a concrete. And we now have, and the North American forest grows enough wood to build it in 4 minutes, and those are really great storytelling devices, but that 88% is the point. So as Carol mentioned, I ended up getting this request to speak at TED. And the single most terrifying thing I've ever done. Bill Gates was in the front row, so they're down in the shadows there. And yet it was also the single most important thing for us as a practice, but also in this movement, because in a way, there's very few ways architects get to tell a story that can reach this many people. And the piece I didn't really understand is the importance of translation. So TED has volunteers that do all the translation, and it's random what countries or what languages they translate it to. But my talk's in like 40 languages now. And I had people come up to me, translators come up to me at subsequent TEDs and say, one woman said, you know, Michael, I translated your talk into Albanian. And now we teach about wood architecture in Albanian architecture schools. And you realize the power of language is so important. This has largely been an English language conversation, but TED opened it up to the world and to many more people, which was really huge. So as a movement, it was really helpful. And Carol mentioned, I used, as a Cornell grad, I used this Roosevelt Island project I knew they were about to build to suggest that if you're going to build a high-tech campus in New York City on Roosevelt Island, you need to build in the most technologically advanced material on Earth, which is wood. And it always pisses humans off that we don't have a patent on this material. That's the way I tell the story, and it's so true, right? Mother Nature is so much more sophisticated than we are. And so I use these as just examples, and they didn't go anywhere. And I talked a lot to New York as a city, tried to talk to Bloomberg's office at the time, and because of fire, it was largely a non-starter conversation, unlike Paris. So the mayor of Paris at that time started asking me to come over and speak a lot in Paris. And why that really mattered was Paris at the time had always been historically the #1 tourist destination in Europe. But around that time, London had been investing so much money into culture that London had flipped the story, and London had become the #1 tourist destination. And so Paris was kind of desperate to figure out, what are we going to do different, right? And they also hosted COP21. So when COP21 happened, they started thinking about how this idea of building in wood could be part of the story. And we submitted a competition entry for this crazy tall 34-story building. We did not win. You can see the Eiffel Tower in there. But for us, again, it was the beginning of being able to show in pretty good detail designs that would get us stretch up into these huge heights. The little blob on the top there is the Eiffel Tower. This was built spanning the periphery, the main highway that loops around Paris. It was a pretty crazy big project. But we didn't win, and kind of scared the hell out of Paris. But enough that Paris decided this is going to be a thing. And I would argue that for the most part, they're building more mass timber than anywhere on Earth right now, even though they have wood there, right? So it's ironic that when you politically have that momentum, it means that you actually see change happen, which is what we're missing in a lot of the rest of the world. We then, again, we're not going to see these very well, so I'll fly past them. Got invited with a whole bunch of architects, Kengo Kuma, Stefano Barre from Milan, and a few others to build. We were doing 2 towers, one in the middle and one just to the side. Kengo Kuma's one's in the distance. A massive revisit of a whole area of Paris called VDA. All in timber, all the buildings. And so all of a sudden we were teaching Kengo Kuma's office how to build in timber, which is really ironic because he's a very good timber firm, but never thought about big, right? And so sadly, this project is still on hold, but it invigorated this whole reality that, again, now in France, throughout France, timber has become massively important and popular. And again, I would argue that tall helped that conversation become important at all points. The next project we'll show really quickly here is what we call T3. And so this was the first building we did for Heinz that became part of the T3 portfolio that Heinz has. This is in Minneapolis. This is a very economical office building. Amazon moved in. Heinz did really well and decided to build a lot more of them. And so probably some people in the room, I know Tony's doing one. I don't know who else are doing T3s. It's kind of crazy to think that at this point, Heinz was really scared of this idea. Now I think it's one of their most popular building technologies. We ended up building it in nail lamb, just to nail together dimensional 2x8s, and that was because that was the most economical thing. And what was really crazy is the cheapest bidder to build this building came from Vancouver, built in just across the border in Manitoba, built a little factory, rented a little factory, built all this structure just across the border, and then drove it down to Minneapolis, and they were cheaper than anybody locally could build this, which is insane. But that's because the industry and the contractors at the time were just scared of new change, right? They wouldn't know. And so it was hugely successful for Heinz, as I said, and for us it was good fun. And it also shows that these buildings don't have to be complicated architecturally to be really powerful. This is a really simple, really economical building with corrugated core 10 on the outside. And yet for us, it's I meet people all the time that work in this building that send me emails that how much they love it. It's the only building I've ever built that I get that much feedback on. And it's pretty cool that that's true. And it shows to me that even really economical solutions in timber are really viable for people that love them. Span through those. There are so many technical lessons I could tell on every project, and I apologize because I'm on the fly, but these are just kind of the stepping stones as we get to as we go higher in the city. This is in Spokane, Washington. This building was our first project doing a lot of prefabrication using CLT, offsite CLT, including the exterior facade system that came in 2-story panels that we hung on the outside, pre-insulated and so forth in the factory. It's a combination of university and office as well. And then we got this project that I never get to talk about, and I'm finally starting to talk about. So Google approached us and asked us to, usually I don't say Google, I usually say a high-tech company that I can't talk about, but you all can Google. Google asked us to do a lot of research with them first to talk about the idea of building in timber for them. And this building was finished actually a year ago. We're just starting to talk about it now. We'll be much more public in the fall about it. Google's pretty constrained. It's very interesting structure in timber for about 1,000 people that work in it. The north side of the building it's all what's called a closed cavity facade. So we're really careful with our glazing. But this is like a facade system that first time it's been done in North America, but it's a fully insulated cavity facade with wood louvers that move up and down inside. The north side, they require all this daylight, but indirect light. And so we manage that with these louvers. And then the south side is more articulated with smaller rooms. And so the north side actually is very tall spaces. In the middle, there's this atrium space, all timber, obviously, and this skylight in the middle. And then just these beautiful, elegant, simple connections, but huge in scale. The floor to floor is 30 feet. It's huge. It's hard to see in the photos to understand the scale of this space. But we're really, really proud of it. For a whole bunch of reasons. It has a raised floor, kind of like we're on right now, to be able to deal with all the systems. So as I said, some of our buildings are hanging systems above, some of their systems, when you have more money, as a Google does, we're able to do everything from below, which means your floor to floor is higher, but you end up not, you get a much more beautiful wood ceiling as a result. And they really liked it. They like this building so much that they're moving one of their most senior teams into the building. And we actually are told this is the head of real estate told me that's their single favorite building they've ever built at Google. And that they will from now on be building in Austin. I don't think I can officially say that. They may change their mind, but that's what's trending, right? That's what this means to people that I think can move the dial in this conversation from the global conversation of what matters. That's Vancouver. This is a little video of the historic building we're working on right now, where we're going to build 12 stories of office and university above this historic building. above through the historic building, and then what was in that drawing, the 18-story residential building is currently starting to head upwards around the 30-story. But because of what's happening in the economy, there now is huge pressure with the developer wanting to push back and end up doing the tower in concrete. So we don't know what's going to happen. This is the university piece. That's Vancouver mountains in the distance there in the water. But again, what's nice is we're seeing the users of these buildings not just be residential, not just be office, but we're seeing academic users and a whole bunch of other users. I'm going to jump forward a couple more, not too many more here, then we'll jump into the conversation. But this is in Paris too. This has just been finished last month. These are renderings. The recording is still around Dublin, so it's really hard to photograph. I think I have some construction photos in a second. This is mixed use, mostly residential, above a ground floor of commercial and second floor office. It's kind of weird programming. France is fascinating. One of the things I do love about France is in their building code, they require every building to have two aspects, every residence unit to have two aspects so that they get crossflow. So whereas we end up building in North America a lot of like single face for each residential unit, and you open a window and the air doesn't flow, they require that you have like these two directions, so you get cross-flow air and reduce the heat load in the spaces. But it's weird because it means that you end up with a lot more cores and it's very different structure. So I mentioned earlier that Andrew's building and most of Andrew's buildings are platform-based buildings, and that's really common in Europe. It makes total sense. We just don't build that way because it's actually not super economical for us to do it that way here. This building is platform-based, so this is our first one that's built in the European style. So what that means is you're seeing more interior walls made of CLT. I think you kind of see them in some other construction photos. So as I say, that building just got finished. It's our first finished project in Paris, so we're pretty excited about it. This project I'm also not usually allowed to talk about, but I'm starting to. It's just finished core and shell. It's just finished construction. It is for a similar tech company as the last one. I'll say. And we're pretty. It's a big building. Again, not super tall, although the floor to floor is tall. But what's interesting is even though this is within 3-minute walk of the other project I showed you, it's very different structure. And again, what this points out is the number of different types of mass timbers we've built with, the number of different structural approaches is enormous. I think we've built 50 mass timber buildings or something. And in that range, very few are identical because we're always looking for the most economical or appropriate solution. In this case, they're big gathering performance spaces that have obviously one unique structural system like this ridge shell. And in other parts of this building, the building was pre-entitled for a different tech company 10 years ago. And we were stuck with certain heights, and to do certain heights in mass timber can be hard because the beam depths to make long spans for the type of office use they wanted can be really hard. And so we hybrided. There's a big conversation and debate about pure wood versus hybrid. In this case, we hybrided it and we squeezed in a whole extra floor, which is huge for them. And so again, those sort of subtle techniques can be dramatically different on the pro forma of the project. And so, again, it shows that's all terracotta on the outside of it. And this is the hybrid. So we're using a system that basically bonds concrete to the top of the CLT and creates this sort of hybrid system to create this shallower span. And again, needs to be added a whole extra floor. So I mentioned Andrew Law a few times in the talk, and like I said, Andrew has become a really good friend of mine. I'm going to see him in a couple of days in Munich. And our firms are kind of working more and more closely together, especially up and down the East Coast. We're starting to work together is our goal. But this is a project in London that we collaborated on. This was for a developer, and it was our first collaboration of the type, but we're still values aligned. And I think that's the thing is this is a small community. Rather than competing with each other, we need to find ways to collaborate a lot to just keep pushing this because we're such a small group of sort of leading voices to push the agenda. I think more collaboration is better. I see a lot of fanning. That's good because we're at the end. I'm gonna end with this, which is 55 stories. This is hopefully it's several buildings. It's 1.2 million square feet. We should know any day now whether this is a go. But I think it will be. And this is very big, not timber. Here in the US, can't say where. 3 towers, including a hotel, office, residential, and this will be our biggest one. This design you're seeing will change a lot. It's literally, it was the initial design for winning the competition. And we won. And so now we just need to get confirmation that it's going to go forward with the city. So we feel really good about it. I think we're going to all see a lot more of these kind of projects. And again, why this matters, and it's ironic, this video doesn't really look up the tower very quickly, partially because it's unresolved design. I think maybe you get a hint in a second. It's a real sort of, this is when 3D modeling is doing the sketching for us. There you go, start to see the height. It's big, it's very big, it's very dense on its site. But what I think this speaks to is the importance of height, right? Again, when we build this, or somebody else builds this, or some of you guys in the room build this scale, it starts to erase the fear of change. And it starts to build the industry's capacity to do this in a cost competitive way. And I think that's critically important, which is the importance of skyscrapers in general. So we'll see if this goes, but I think it will. That building on the left, the hotel. And our partners on this are very, very, very positive about it. We're already doing a big timber building for them, and they're really committed. So I think this certainly won't change structures. It's more just a question of whether we get quite that big. So 2 last slides. We do have a new edition of this book coming out. And why this matters, this isn't about us at all. This book is really about everybody else in the industry that's doing this. And this will be our 3rd edition of it, 3rd complete transformation of the book. But the idea is to capture what's happening globally in the industry and really celebrate it. We'll keep doing these for a while. It's a great way to not make money. And yet it's really, really important. When Burkhauser is our publisher, and they're a Swiss publisher that I love, I think make the best technical books out there for architects. But when Ria Stein, our editor, and I first chatted like 12 years ago about this book, she said to me, yeah, that doesn't really sound like something anybody would be interested in. But we can do a small run and see how it goes, but we won't really promote it. It won't really matter. When I started flying out to come to this, she called and said, "Can you make sure to promote the next book? We're sold out already. We need to do another one." A lot of changes happen in a pretty short amount of time. And anybody that tells us that the ship can't be changed or turned or dead wrong. It takes us, and again, like it's a privilege to speak to folks in the room that are so values aligned. It takes us really stepping up because the voices of our industry are still talking about style. They're not talking about impact and meaning. Good buildings are not about what they look like. They're about what they mean to the community, what they mean to the planet. Style and aesthetics are easy. Like design is easy. The hard work is difference. That's what we should celebrate as an industry, is difference making. We need to celebrate people that actually solve the seriousness of the problem ahead and transform whatever business you're in to make that happen. Being leaders is hard for all of us. Great time to lose my voice again. But the truth is, this is history. This is absolute history. There's no doubt in my mind that our industry has not seen any significant change in a century other than this. There's been some important transformational materials, insulated glass, better performing facade systems, passive house. There are important innovations, but this is one of what we need 1,000 more of these ideas. What this has shown us is that big change can happen, right? We can make this change happen, but we have to actually drive it as architects in particular. Right, as developers, as leaders. If we don't drive it, no one else will. Government's not going to do this. We have to do it. We have to help. We have to show the public why it matters. And the way we talk to folks and the tools we use to communicate matter. This isn't a time to talk in arca speak. This is a time to really connect with everyday people and show them why this matters to their lives. Denser urban environments are the future, but they have to be way better than what we're doing. The new towers here in this city that are all glass. I can't even believe people build that shit. Dinosaurs, call them out. We have to start changing the tune of what we do, because if we don't do it, no one else will. And so with that controversial comment, thank you.
Thank you, Michael, that was great, and I kind of love that the best thing that ever happened to you was being misquoted by a reporter.
That's true. Pretty true.
It's a little ironic. So my first is, I don't know that it's really a question, it's sort of an observation that we're in the Skyscraper Museum. The focus is really tall buildings, and even in the show, the tallest completed building is the one in Milwaukee that's 6 stories, I think, in the world. Your practice has, your presentation was very focused on tall, but there's sort of an irony there that the tallest building that you've done so far is maybe Flora over there.
Yeah,
Right.
yeah, that's true. There's a reason, which I hate to admit. And I know my friend Andrew would say the same. There is a point in super tall buildings that we have to rethink how they work if we want them to work socially. I actually have real challenges as an architect seeing the way we're building tall, especially the tall residential, without a kind of conscious decision on how people create heat. And so I just haven't had that sweet spot with a developer that understands that's transformational as much as these kind of conversations. So we lean against, we won't build when somebody asks us to build in steel or concrete, we just say no. And if we're not able to kind of meet our community objectives as well, we offer this.
That opportunity hasn't come in, but that 55-story tower sounds.
And it's got good community stuff going. Yeah, which isn't like an amenity building in the basement. It's really throughout. It's to build a small scale community. So that's something that we're really passionate about as well.
One of the things that I've been long curious about wood is that, or whenever I've written about wood, I always say there's always like a disclaimer in my articles of like, if responsibly sourced, then there are all these benefits that follow. Carbon sequestration, great ecosystems, et cetera, et cetera, et cetera. So but it's very hard to put your finger on what that means, that responsibly sourced wood means. What does it mean?
So it's a really, really challenging topic because it's both carbon isn't generic to the material. Like it's very specific to where it's harvested, who works on it, what the fabrication process is. You get a totally different carbon outcome, and the industry doesn't yet understand that sophistication. That's hard to do. But also, as you say, it's, we should not honestly be cutting down trees in a lot of the world. That's not what we should be doing. Only in some parts of the world, really northern hemisphere, some very limited parts of the southern hemisphere, do they actually have sustainable forestry. The problem with any concept of sustainable forestry right now is none of us actually know the outcome of all this climate impact, right? So for the forest fire issues, forest management issues connected to sustainable forestry, and even where what forests will grow back, all of that is a little unknown. It's not all the predictability we had maybe 25 years ago. We just don't have anymore for sustainability. So it's a huge concern. And it's enough of a concern that I don't know if you've seen the TED talk I gave last year about 5. Have you seen that one? So for all of you in the audience, I gave a talk a year ago called 5, which is basically if there's 4 major structures that built the planet: steel, concrete, masonry, and wood. That's pretty much true of every city in the world. If we knew based on, the impact on climate a century ago, what would the fifth have been? What would have been the real material we invented, right? It was a conscious choice. We chose steel and concrete in the absence of the information of how harmful they are. But the answer in my mind to that is plant-based technology. And that is, the idea that everything in this room could actually be made from a plant with today's technology. There's nothing in here that we can actually replicate with plant-based materials already. If that's true, what's the future of structure such that we don't have to cut down the forest? Because this idea is good for now, it's not good forever. This idea is only a moment in time. And this idea isn't good. And a lot of the world, which is the middle belt of the world where most people live, those are also the most vulnerable forests in the world where we can't actually sustainably harvest it. So, the answer is A, it's hard to figure out sustainability. We use FSC mostly as a metric, as one of the certification systems. That's imperfect. It's not equal from location to location how they actually evaluate sustainability. But also, it's important to know this is the best solution we have for now is not the end game. And we have to be investing today in what's next, which I believe is plant-based structures that I call.
So we'll be making wood in the lab,
It's yeah.
burgers.
Yeah, so trees are vascular plants. So all vascular plants, right? Almost all plants that we're used to seeing are basically cellulose and lignins that bind, and those two properties can actually be reconstituted to make strong products with a lot of new understanding of how to build robotics around that. We can actually start to create our own version of plants. Not necessarily growing them, but actually breaking down to cellulose and then reconstituting, kind of like microscopic cross-lamination. And if we can get that right, there's a whole bunch of, if you guys watched this TED talk I did last year, there's a whole bunch of sort of ripple effects. Our belief is that in wood and in a lot of structure, we overbuild by about 25% the material wastage of bad design. So when you think about beams in a wood building, they're squares, right? Trees are round, beams are squares. The true structural properties of a beam, if you look at the way structural forces move through a building, are much more organic in shape, right? The forces of tension and compression move fluidly like nature. Because of that, a lot of the beams we build, certainly in wood, this is true in steel and concrete, a lot of that beam is actually not under the kind of load needed for the material. And so we could probably cut away 25% of that material. But that's not the way the industrial complex is organized to build concrete beams. They're cheap to build in rectangles. Wood beams are cheap to cut in rectangles. That's because they're both subtractive materials. So you make the material and then you cut it away for efficiency, which just means more waste. If we move to additive-based systems, which is plant-based technology, it means that we're actually going to only build with the material necessary. So it's not 3D printing, if that's what's in your head. 3D printing has other kinds of inherent problems, but it's similar to 3D printing. It's just building the shapes that matter. It means our buildings will look more like the forest because it's actually following the true structural properties and reduces about 25% wastage by volume on Earth, because we make the most materials to need to serve buildings. If we could reduce even 5%, we're talking staggering economic outcomes, right? I often say that our industry, why we're so bad talking about this stuff, is because we're not embracing some really important statistics. And that's that because the materials we use are the largest volume of materials made on Earth, it means we have power and agency that we're not using. It also means that when we can become more inventive and efficient, we probably hold the keys to the biggest economic change in human history. If we can develop a system like a plant-based structural system, it's literally, the scale is so big that it's the largest economic conversation. That's the power of innovation in our industry. And if you're an architect in the room, I always look to our mentors, right? Like the Corbusiers and the Kahns and those that really explored structural materials to make a new architecture. Well, that's what we're in. But it's actually CLT is a stepping stone to plant, which is nice. And that'll start to solve this big question of do we have enough trees? Should we be cutting the forest down? The answer is no. And we have to grow other materials and use more waste product. The largest material by volume we create as a waste product on Earth is agricultural waste. That's all future structure. That's all that fiber is all usable to make buildings in the future. But no one's really pushing that technology or conversation.
And it's,
Except for David Lewis, who's going to state them.
Yeah, I mean,
LTL.
as far as like a big change, right? We don't have that yet, but we have like a whole bunch of inspiring people pushing it, but not yet in a certain global scale.
right, and I read somewhere just recently that it stores carbon more effectively.
Yeah, depends, like, everything's like kind of depends is the
Yeah,
problem.
right.
But it, like, as with all climate conversations, everything's a yes and, right? It's not a yes or, you know, it should always be like, this is good, that's better, let's do both. Let's not just constantly cut down good solutions, let's do them all, right?
So in the near term, or this wood-like material that will be developed in the future. But in the near term, as this technology, as mass timber grows and it becomes a larger market share, how do we do it responsibly? I mean, it's like it's only like, it's just a teeny bit of a construction market now. I don't even know.
Approximately 1%.
Right.
Yeah.
So if it grows, how do we responsibly meet demand?
So we can only meet to a certain point, is the truth, right? We can't we can't regrow the forest fast enough to meet demand if we saw like a 10-20% change to the industry. But it's a yes and. We need to push this because we're a long way from 10% of buildings in cities, but we got to get to 10% pretty, sooner rather than better. I think that this conversation is also just, the tip of the spear as far as the climate conversation. This is basically saying these innovations matter. These are the beginning of all innovations that need to be employed. And if we can show that this one can be changed, building codes can adapt, the public can adapt, that people like the buildings, it means that we can create more opportunities for other changes.
So where do you, so now we have an IBC code that cities can adopt that permits up to 18 stories of mass timber. Where do you see lots of adoption? Do you see it changing? I know that 18-story, if you build up to 18 stories, it requires lots of protection, like encapsulation for the wood. Do you see that becoming a little looser? Taller than 18 stories? What do you see in your crystal ball?
Yeah, I think that we'll see, I mean, what I dream of is get rid of all these arbitrary heights. They're completely, we don't have height limits on steel and concrete, wood. It's about safety, prove a building safe, employ the right safety measures. There should be no limits on what we can do. That's moving away from these very prescriptive codes that we have in North America towards a performance code. That's essential. Code authorities are slow, so there needs to be all these alternative measures that will allow us, alternative solutions that allow us to go around them. We as a practice owners never built the code. Like, we just want to say it's a good guideline, but like there's a way around it. It's a good idea. You just have to get the right people and right testing to be able to prove whatever it is you want to do. The roadblocks aren't really the code a lot of the time. It's a lot of the time it's fire departments. A lot of the time it's local authorities. So we have a project where we're going to do 400 residential units in a really beautiful mountain community just outside of Vancouver. And it's like so values aligned to build it in timber. The views are all glaciated mountains. And everybody there is like outdoorsy and wants this. The problem is the fire department doesn't know how to fight a fire on 8 stories. And so they don't have a truck. They don't have the skill set. And so they'll say no. And our argument is, well, it's going to take us 4 years to build it. You think you might have that stuff in 4 years? And like, luckily at this point, the way we get around stuff like that is I called, the head of, we actually have in British Columbia, this is amazing how supportive I feel. We have an office of mass timber it's a political office under the Premier, Premier's like our governor. And so I just called them and said, can you guys get these guys a fire truck? And can you guys? And they said, yeah, like they didn't know, that's the obstacle. And so the more we vocalize solutions and talk to the politicians that count, the better. And the politics of this is interesting, right? It's gotta be in this sort of, it's, you know, all of us know it's really hard to get politicians to think in the long term. So, you know, pitching this on the right and the left is really, really important. Finding the story thread to convince the right and the left to go with the same idea is possible with this, because there's huge impacts on rural jobs, which helps the right, and there's huge impacts on the environment, which helps the left. And so we've learned the language to be able to get everybody politically aligned, but it's work for sure.
Any more
questions?
Yeah, I have some more. So if we're gonna solve the climate crisis or reduce the architecture and engineering and construction industry's impact, we probably have to just build less.
Yeah, we have to protect more, renovate more, preserve more, build less when we don't need to. But, you know, we're driven by our pocketbooks, right? So it's hard for architects and engineers and builders to stop the machine, right? It's very hard. How do you earn an income if you stop the machine? And so these are big challenges for us. And, you know, less so here in North America, but the rest of the world needs buildings,
right?
Needs buildings, right? Like, you know, we're gonna see, we expect by end of century 1 billion people to migrate as a result of climate. Like, beyond just the sort of political impact of that and the kind of, you know, issues we're barely seeing, especially here in this country around immigration, it's going to be out of control. But that also means where are people going to live? What kind of housing are we going to build? Where are we going to build? Are we going to be more like China, where we just build whole new cities instead of densifying our existing cities? Are we just like building all new cities, which is arguably the right thing to do? You know, start fresh, fix systems, build better infrastructure that's actually climate forward, rather than expect us to hold together these pretty broken cities, maybe with broken infrastructure. So these are big existential questions.
I want to come back to that housing, but where I was going with that was Mass Timber's role in renovation and adaptive reuse. You had one, you showed one project. I wonder if you could talk a little bit about how its appropriateness there.
Yeah, so here's another code challenge. So it depends where you are. It's a great solution that you see a lot in Europe of build on top, right? So adding 2 more floors for developers to get a little more density on their existing buildings. Because of Mass Timber's weight, right? So lots of people know this, is that it's the most likely solution for a reasonably tall building to add on top of, because you're not going to overburden the foundation system. The failure of that is the way the code operates in seismic regions. So as seismic code is getting more stringent, a lot of their existing buildings no longer, you almost can't renovate them, because the moment you touch them, they basically trigger new code updates that are cost prohibitive, let alone add on to them. And so again, our code is our worst enemy in many cases here to solving some of these problems, because, you know, we are, instead of, and I think AI is going to help us a lot with this in the next 5 years. We're really bad at understanding the big macro cost of things. And the big macro cost of climate change is so much bigger than the very small risks that we attach in the building code to life safety issues, and we're constantly making a little bit better. You just add up human lives, it's not even close to the same conversation, right? So we make our code so complicated that we can't solve some of these bigger climate objectives and innovation objectives. But we're doing it for very, very small impact on life safety issues. And those have to get realigned. And it's because we're so bad at understanding the real cost of climate. That's going to change. AI is going to help us. AI is going to help. That's a much bigger life safety issue. Many more lives lost because of it. So that's where AI is going to help us do much deeper dive analysis into true cost. So I actually gave a TED talk last week on what I call true cost, which I hope our industry moves to. Because I've really thought, and this conversation has been a big part of it, why don't we innovate as an industry? Well, there's no incentive really to, right? Like, how many of us as architects in the room or engineers where developers just want to know what's the low cost solution. Well, that's based on the hard costs, materials, labor, and soft costs. And that is all we talk about. But there's no additional cost to planetary costs. There's no additional societal costs, which includes healthcare and impact on mental health added to your building costs. Therefore, we don't innovate for those things. And so the big push, I think, with AI is going to be understanding true costs. And that'll help us actually make these solutions the lowest cost solutions, because it will encompass all these other costs, including carbon that we don't put parts into. I think within 5 years, AI is going to pull back the curtain on that conversation, and humanity's going to have to revisit its sort of priorities here pretty big time, because we see what it really is costly in lives and capital.
I hear most people talk about AI with trepidation, but it's interesting to
I have
hear you.
a director of AI in the firm.
Oh, wow.
Yeah.
Well, I wanted to ask you about housing, but maybe about housing in the global south, but
Yeah.
maybe we'll talk about it
Yeah.
afterwards in more informal
So-
setting. Thank you.
This lecture series is in conjunction with the exhibition, as I said, the tall timber, the future of cities and wood, which attempts to give a chronology and a short history of the mass timber movement in North America in particular. And that is the history that's only about a decade or 15 years long. Michael Green stands at the beginning of this history, and I'll show you in some of the slides later, but as you in the audience know, you are sitting in the space that you are seeing here in the video and in the installation of the show. And here's the overview for this lecture series. So a short history, as I say, concise and really small and identifiable in the figures who really have made a difference in advancing the ideas of mass timber as a material, as an industrialized material, as a biophilic material, and as a material that solves and helps to solve the problems of climate crisis, which is the larger context for this exhibition, and underpins the urgency of these issues. People who have spoken already in the series, which began with Chris Sharples and Thomas Robinson, who's sitting in the middle over there, talked about, because I asked them to, the beginnings of the and the bicoastal beginnings with the models that are in these two cases of the winners of the competition, the Tall Wood Buildings Prize back in 2014. And they showed their work, and Michael is the second of the lecturers of the architects talking about their work in the perspective of this decade or so of their experiments, their prototypes, and their aspirations to expand the world of mass timber. On June 4th, Susan Jones will be joining us, and it's important to note the importance of regionalism because Michael is from Vancouver, Susan Jones is from Seattle, and Thomas Robinson is from Portland, Oregon. And that ethos of the forest, as well as the aesthetic of timber, is deeply embedded in those regions. And that's one of the issues that we look at in the exhibition. Another one is the role of academics. And in the June 25th lecture and panel or program, we're bringing together Alan Organsky as well as David Lewis to talk about their work, but also to talk about the academic milieu or the kind of front of academic research at Yale and at the New School in conferences that brought together a lot of the figures who will speak again in this series and be able to reflect on the history. So back in 2014 and in 2015, at the very beginnings of timber in the city, and Andrew Bernheimer is here, did an important book that's based on that work in those conferences at Parsons and the New School. And then another, and not the last, but the last announced so far of the Tall Timber series is height and hybrids. As we ask structural engineers to think about the application of mass timber for truly tall buildings, And those who have practiced and those who have theorized, including Benton Johnson at SOM, of taller buildings and of optimization of fiber, and another way of optimizing materials in hybrid forms. So it's a bit of a debate between height and hybrids. And others who will join us in the series are Andrew Waugh from London, who will talk about his work and talk about the progress in the evolution of mass timber. Already in this series have been the kind of prologue, Designing the Forest, a book by Lindsay Wickstrom, who apologizes just a moment ago in my email to say she couldn't make it tonight at the very end. But she, you can listen to her lecture about her book on our website. And then Michelle Roloffs from Arup and Tanya Luthi from Timber Lab gave a kind of primer on Mass Timber 101 for those unfamiliar with the material. But tonight is about Michael Green. And I asked Michael to talk about the history because in our very first email exchange, he was very kind to put together a kind of chronology of his, which I was familiar with already. He was prompted by me in order to do this, with his early work and then continuous focus on high-rise buildings. And so Michael has a history that is goes back to 2012 and a book that you'll see in a moment. But first, let me say, Joanne Conjar from Architectural Record, where she's deputy editor, has been on this case for at least a decade too. And she really is the specialist who has spent the most time studying and the most intensive reporting on the mass timber movement and interviewed many of the architects here and in this series. And this Wood Empire State Building, which is a theoretical project that Michael did with Eric Karsh, who will also speak in the series of height and hybrids, is one of the first reports and endeavoring to, as you see in the title, make continuing education a part of the enterprise of education in mass timber. Many of you may know Michael from his TED Talks. He's given several. But this one goes back to 2013, and it's as you can see on the screen, why we should build wooden skyscrapers. And you see the Lego piece, and that's one of his interests is in prefabrication and the kit of parts of wood. But what's clear from over a decade ago is, and in these studies that illustrated the case for tall wood buildings, which is his 2012 and then published in 2017, this book, which included that drawing that you see there, and his most recent, but soon to be reissued Tall Wood Buildings book that brings up to date his work in material. In this span, or this kind of bracketing of inquiry, the buildings that Michael has completed are mostly, I'm not going to call them small, but they are multi-story. But a continuous theme throughout his work, at least as I've seen it, and I read Joanne's many articles and reports, where you dig into Michael's work, there is always this interest in the tall building. And that tall building and multifamily buildings and multi-story buildings in office is a way to approach urban density, which is the other way to approach to solve the problem of climate crisis. So this is also a screenshot of Michael's 2013 talk for TED. And in the background, you see a project for an unsolicited proposal, a visionary one, for what became the Cornell Tech campus on Roosevelt Island now that we all know. An incubator, a place where technology and science are celebrated. And in this scheme, which he did as a Cornell graduate, I think somehow connected to Cornell, he proposed the first 30-story buildings in wood more than a decade ago. We thank you so much, and we could go on all night, and it seems that you've been too, so we're delighted that you have devoted Well, we're delighted at your commitment, which is so clear in everything you do, and just simply being here and talking to this audience is all a part of the mission at all the scales that you operate. So thanks everybody for being here tonight. Thanks everybody who will see this in the future. And thank you, Michael Green, for everything you do.